Okay, good. So, by the way, before going into, hey, why I cannot see anything here? Yeah, here we go. In my grasshopper, wait a second. Where is my grasshopper? Here. In my grasshopper, sorry, because I'm receiving here more notification of participants joining the class. It's a bit tricky. Yeah. In my grasshopper, let's going to let's going to write a number. Okay, double click. Remember how to write a number in grasshopper. You can do with double slash, okay, and you get the panel. So you can do. Let's going to write the number 135. Okay, let's press enter. All right, so this is a number, or another way of writing a number can be, for example, 0 is smaller than 140, right? If I do it like this, check. If I do it like this, I will have integers. I will have a number slider. I go from 0 to 140 with integers. But I can do like this. 0 is smaller than 140 dot 0. Or 0, 0, 0, for example. And I want 3 decimals. If I press enter, then I will have a double. This is an integer. This is a double. Okay, so here you can see that I can change the decimals. Okay, remember that to change the number, I just double click here, for example, and I want for 53.67, right? And I have the number. Okay, so I have the, let's gonna keep on working with this number, 135. Okay, and now let's going to double click and let's going to do a division. Division is called. Okay, let's going to do a division and a multiplication. Okay, so let's going to enter in the division with two numbers. 2, enter, 3, enter, and let's going to connect it here. Oops, 3, enter. Yeah, you see, if I put 0, 2 divided by 0. Do you know how much is 2 divided by 0, by the way? Did somebody knows? Division by 0. In mathematics, if I divide 2 divided by 0, somebody knows? No? Wait a second. Hey, so if it doesn't work. 2 divided by 0, I cannot do it with grasshopper. To be honest, don't know why. Why I have a, it's the first time that I do this thing, to be honest. But I don't know why is having this fault. Well, let's gonna put 3, 2 divided by 3. Okay, and it's 0.6667. So now let's going to multiply. This is the number of students in the course. So if I connect this one to A and this one to B, I am going to have the number of students that should be connected on every class, 90. Okay, this is a stupid example to use grasshopper, but this is also good to practice. Okay, so guys, on every class we should be around 90. Okay, I'm going to be also flexible with the number. That's perfect. We are 88. Okay, this is super. But yeah, on every class we should try to be around this number. We are more actually because I have to admit the participants. I will be looking from time to time. And Elena, maybe I can make you co-host and you can help me with this. You can admit people, okay? You can admit the students in the class, okay?
Course, co-host.
Sorry?
Of course, just make me to a co-host.
You are co-host already, okay? So guys, well, this is a stupid thing. How to show you that you can use also Grasshopper for this thing. I know I have some friends that they have done their CV in Grasshopper. I don't recommend this. Okay, I don't recommend this, but you can do it in Grasshopper also. So well, guys, we were working with booleans. Okay, what is a boolean actually? Well, today we are in class number 4. We are here, list and sets, transformation number 1. And today we have the first partial submission, okay? The first partial submission, I think, is on Ilias already. Give me 1 second. Submissions, intermediate submissions, intermediate submission 01. Submit a JPEG and image, please. Image of your intermediate submission. I explain you how to extract an image from Rhino. So I think that I have it. Execution, preparation classes, templates, intermediate submission. I think that I explain how to obtain a JPEG, please, no PDF. Okay, don't send me a PDF, send me a JPEG this time, okay? With classes 1, 2, and 3. And the deadline, I think that I put it for Sunday in 2 days and 13 hours. Okay, I think that is Sunday evening, the submission, so you also have the weekend if you cannot do it before. But please, from here, I'm going to explain it again. When you have here placed your images, to produce an image out of this, you can do Control P and use image file, select image file, and then just print. Okay? I mean, you can select the quality also. I mean, it doesn't need 300, but yeah, maybe 200, more than enough. Normal quality. You can select normal quality. Okay? Let's go to print. And then you save your submission. Okay? And then I should have it somewhere in my desktop. Here we go. Okay? So this is what you need to submit. An image. Okay? Submit an image. And that's all. With your name and surname, please. Okay? So, yep. So, today, class 4, okay? We are going to talk about Booleans. Booleans is something that is called data type, guys. A data type is a point. A data type is a curve. A data type is a B-rep. All these black icons that we have here, they are called data types. We have one of them that is Booleans. Okay, I'm going to place it here. One of them is Booleans. Okay. It comes from George Boole, okay, who developed this concept, okay? The Boolean, this is the important part. Boolean data type is primarily associated with conditional statements, which allow different actions by changing control flow depending on whether a programmer specified Boolean condition evaluates to true or false. Wow, a bit convoluted, right? This definition. What does it mean? Humans usually we can reply, I don't know. Annalena, is your computer hot or cold? You don't know, right? You will tell me, well, you touch it and then you say, well, it's hot or it's cold, depending on what, on your own experience, let's say, no? Booleans and usually computers works the other way around. Hot or cold depends on, for example, the temperature that you specify, right? I tell you, well, Annalena, is your computer hotter than 20 degrees? Then you only have two options. Measure the temperature in your computer and then say, well, if it's more than 20 degrees, it's true. And if it's less, it's false. It's a relation based on numbers, okay? Something that is completely, let's say, specific, okay? It's not something that can be, it's not a fuzzy logic. You have here the example, right? Yes or no, this is Boolean, and fuzzy logic is very much, fairly so, moderately. I mean, this is all the answers you can give, okay? So, usually Booleans, we use two components in Grasshopper. I prefer to explain those components while we are working in the class, okay? But those two components are cool index and cool pattern. Okay, you put a pattern, true, false. True means that the first one you have a list, okay, of spheres, and you introduce this pattern. So what you're going to obtain is just you will have the true, false, true, false, true, false. All truths will be added to your list, will be keep it in your list. The false will be deleted, okay? Or cool index, which means that you are going to only keep or delete, in this case, one index, okay? You have this list of spheres. So I am going to delete the index number 0, that will be whatever. I'm deleting 1, okay, for example. So let's going to see how we can do this example with booleans, okay? For this example, I'm going to do it in this, let me 1 second, I want to copy this panel here to divide the content. I'm going to make this thing bigger so you can see it better. Yeah, so I have this plot, right? So what I want to do is on this algorithm that I have here, I'm going to hide this one. I want to delete some of these surfaces, right? That at the end, remember that we divide the plot, we calculate the distance with an attractor point, and then we extrude them, okay? So I'm going to copy paste all this code because it's going to be exactly the same. But now let's going to think together how to apply booleans here, okay? As I said, booleans are, let's say, conditions that can be completely checked, like fully checked by our computer with no question on all of this. For example, could I say like, what can we do? For example, I draw here a rectangle, okay, which is this one. I put it inside. One possibility will be, well, all these pieces that are inside this rectangle, I want to delete them from my list, okay? The thing is, what means inside for you? That could be done in many ways. At the end, we will need to go. The booleans usually work very well with data types. For example, numbers, points. Okay, check if one point is inside one box. Check if one number is smaller than another number. That usually works pretty well with booleans. Okay, so what we are going to do is we are going to check if those surfaces are inside. For this, I think that the best will be calculate the area, the center of each one, and then find if those points are inside one geometry. Okay? We know already how to calculate the centers, right? This is very easy. Command area. Okay? Area command. And here we go. Okay? So we have a list with the centers. Now, how to check if these centers are inside my rectangle? There is one command called point in brep, or point in brep. Okay, so you specified a brep for inclusion test, a point, and if it's strict. Okay, and the output of this check, you remember this icon, right? This icon is a boolean. Okay, when you see this circle, half of it colored in black or white, this is a boolean. Okay, so we have the points. The points come out of the C of the area. Okay, but we need the brep. How can we do the brep? And here comes the tricky thing. Let me explain you here. Points, this is my plane, right? Good. My points, I'm going to draw in red color. I really love the grasshopper canvas to explain here using grasshopper. My points are specified exactly in this plane, guys, okay? Okay, and then what I'm going to do is I'm going to select, let's going to change the color. It's cool, this thing, no? Let's gonna change the color. And what I'm going to do is I have this perimeter here, and I'm going to extrude it. Oops, sorry. And I'm going to extrude it to create like a box, you know, where I can test if those points are inside this box. The problem is that those points are exactly on the edge of the point. This depends then on the accuracy of your Rhino model, okay? How we are going to avoid this issue? We are going to extrude the box, but then later I will move it down, okay? So the box at the end is like this, and the test will be, you will avoid every type of problem. Okay, this is very common, let's say, workflow in Grasshopper. When you are testing themes, you try to avoid as much as confusions as possible, let's say, because otherwise, for some of you, this will work, for others will not. Okay? So let's going to draw, I'm going to do everything with you guys. Let's going to draw here a rectangle, okay? Sorry, because I am doing it in this small part, okay? I'm going to draw here my rectangle, okay? And then I am going to put this rectangle inside Grasshopper. How to do this? Double click, curve, okay? And we have the curve component, so right mouse button, set one curve. And we select our curve, okay? Now it's inside Grasshopper, okay? Okay, so now what I have to do is extrude, double click, extrude, okay? This curve, this is the boundary, extrude upwards, okay? So upwards is double click, unit set. This I think that you already know, right? We did it with the buildings, it's kind of easy workflow. Unit set, so I specify, I don't know, let's gonna write 5 meters, okay? I don't want to make this like parametric. 5 meters upwards, done. This is our box, okay? And let's going to cap the holes to create a solid volume. Okay, if we cap holes, we create this solid volume. This is the same process that we follow with our buildings, okay? So we have our box. Now, what we need is to move it down. Easy again, no? Double click, move component, okay? Then unit set, because I want to move it down. Unit set to create a vector in the unit set direction. And how much do we want to move it? Look, just 1 millimeter will be enough. Okay, let's gonna put -1. And this is important. I want to move it down. So the vector is not positive. By default, positive vectors are going upwards, negative are going downwards. Okay, so we put -1 here and connect this vector with this movement, and then we move the box down. Sometimes it's a thin grasshopper, no? You tell me, oh, Javi, to move a box, I need to do 3 components. Yeah, I mean, sometimes it's like this. The thing is that you need to think that you are not moving a box. You are moving every box that you made out of here, okay? So this is why sometimes things with grasshopper takes longer. Depends on what you want to do. Of course, it will be simpler to model this box in Rhino, move it downwards, done, and put the box directly into grasshopper. That could be also the workflow. You see, all these components is the same as box. Select the box, move it down. Okay, and then geometry, geometry, and then put set one geometry and put this geometry inside. It's the same, guys. But if I can make here, I mean, of course this is longer, but this is prepared for one thing and this is prepared for another thing. This is faster, but not parametric. This is slower, but it's parametric. Okay? Difference between right and grasshopper, basically. So, okay, here we go. So now, here that we have our box, okay, let's gonna use it for calculation. You see, once I put this thing in, I am calculating the booleans. So let's see. I have a lot of false, but somewhere in my list, I should have truths. You see? False, true, false, true, false, true, true, false. Okay, so I have 275 points, which is the same as my initial points, 275 boolean, sorry. And then what I need to do is filter what? Filter this list with these booleans. Guys, the key feature here that I need you also to understand when we use booleans, okay? Because from now on in the course, we are going to always use booleans, okay? Booleans, this works because this structure and this structure is the same. What I mean? This is working because the path that I follow, the workflow that I follow to obtain the booleans haven't changed the structure of my list. Okay, so basically surface 0 is related with boolean 0. Okay, and so on and so forth. And I have 275 surface, 275 booleans, 276. Okay, always one more. But this works because these have the same structure. Okay. Sometimes take care because when you create the booleans, you have changed, for example, if this component now, I don't know, I do some modifications here or whatever, this list is not the same as this. So it's not going to work. Oh. Let me 1 second, guys, because I think that I have a problem with my computer. Can you hear me, Annalena?
Yes.
Yes. Let me 1 second. Okay, 1 moment. Okay. No, it's not working for me. Guys, are you here? Annalena, can you hear me?
Yes.
Yes, sorry, guys. I think 1 second. I need to close Grasshopper. Let's see. This is a problem that I have with my computer and the graphic card. 1 second. I'm gonna close this. Yes, to save. Let's going to reopen it. Uh, 1 moment, please. Recent classes, class 4. No. Yep. So what we need to do, guys, now is, since we have the same structure of booleans, is use this structure to filter. How to filter? We are going to use, for example, cool pattern. Okay, cool pattern component. Use the booleans to filter whatever type of geometry. So we're going to open our grasshopper.
Excuse me.
Yeah, Kemi.
I have a short question.
Yeah.
I still see the structure that we did in last class on my Rhino, and it's kind of distracting me, and I'm not sure how to turn it off, but still have the, like what we do now, turned on. Because if I
Okay.
click on the,
Yeah.
yeah,
Good question, Kemi. The key thing here is that when you are developing your definition, I recommend you to work with the only draw preview geometry activated. This one, activate the green one. Because if you activate the green one, that means that you are only going to see in Rhino what you select in Grasshopper. Okay? That works for you, Kemi?
yes,
Yes. This is the
thank
way
you.
to go because yeah, check it. Very likely will be worse than yours. Check. If I deselect it, you see, it's impossible. I cannot work. You know? So I select it, and then I am going to continue here. Okay, so let's going to apply those booleans. I will show you what is this flatten and graph. Let's going to apply those booleans into my list. Okay, to apply it, cool pattern. Okay, cool pattern. We have this list of surfaces. Okay, this is the list, and this is my list of booleans. Okay, what is happening here? It's working, the cool pattern? Do you think it's working, guys? I think so, no? Because seems that I only have now the surfaces my inside my curve. Inside where is the curve? Ah, here we go. Inside my curve. Okay, this is my curve, which I don't know why I cannot see it. This is my curve, okay? So I have I'm going to hide also these elements from the previous class. This is my curve, so I have the surfaces inside. The problem that I'm having is that the pattern that I'm doing is true if this thing is inside, if this rectangle is inside my surface. So then when I come here, what I say is that I want to keep those true and delete the false, which is actually the opposite, what I want, you know? This is very easy. We only need to invert the booleans, okay? So if you do here, right mouse button, invert in the P, in the pattern, then you will have your list filtered. Okay? With the cool pattern. Okay, guys? And then it's a matter, now the only thing that we need to do is change this last part that we did last time from here to here. To do this is very simple. We can go one by one reconnecting, okay, which are two, or one trick, press Ctrl Shift, click here, and click there, and you are moving everything together. The problem is that you need to connect S with L again because you have lost the connection, and also, oops, sorry, and also from here to here. Yeah, like this. Otherwise, I recommend you just to do like this and like this, which are the two wires that they were connected. And then here we go. Here we have our project, which is extruded, only the part that is inside. It's still working as expected because I have here my attractor point. If I move the attractor point, this should work also. Okay. It's also working for you. I can change the subdivision of my surface. I am going to make less divisions to my building. Okay. I want to make this courtyard bigger, or I'm going to make it smaller. Only this part is going to be my courtyard. Okay. And I want to have it, as we said, the hide the smallest one I want to have for example, here in the corner, no? And I want also that my building is smaller. So how to do this? I remember that it was 50 here, so I want this thing to be smaller. Okay. It's working for you guys.
Excuse me, could you maybe repeat the last steps? For me, it's not working.
Yes. Yes, of course, Maren. Let's going to have a look together again. So, Maren, until this point was clear, no? Until obtaining the booleans, it was clear, right?
Yes.
Yes, okay. So this part here is to get booleans to filter. Okay, this is what I'm doing here. And then I use the cool pattern, okay, to filter those surfaces with my booleans. So I use the cool pattern here. I'm going to quit this invert. So I'm going to use this cool pattern, okay? The problem of the cool pattern, Maren, is that I need to invert the list of booleans because otherwise I am keeping only using the center, the ones which are located in the center. So right mouse button, invert, okay? And then I keep my building.
Invert it. If I
Sorry,
click on
Maren.
it, and if I click on cool pattern, I don't have, I can't see inverting.
Yes. Yes, don't worry. I mean, this is a bit tricky. If you click here in the center, it's not going to work. You only see this, okay? You have to click in the P. Go to the P, put the mouse there, right mouse button, and then you should see the menu.
Yeah. Ah,
Invert,
okay.
okay? And then you have this. Then with the cool pattern, you need to connect the cool pattern to the distance, to the area here, and to the extrusion that you have here at the end. And that's all. Let me make this bigger for you to see if it works.
Ah, yeah, now it's working.
Now it's working, right? Okay, it's a bit tricky, but
Thank you.
this is, you're welcome. Filtering, okay. So now Maren, play a bit with it, okay? Check it if it works, because usually it's the way of checking if Grasshopper thing works, playing. Like I select this one, and then let's gonna change parameters here. For example, I change the amount. I want more divisions. Take it with the divisions because usually you put a lot, it's going to freeze your computer, okay? I change the attractor point from here, for example, I want it there now, or I want to go up, Like if I go up, take a look, this seems like there is like a curve here, right? It's like a hole. It's cool. Okay. So you can have it like this.
I
Okay.
have a little question.
Yeah, Bianca.
When I do this, it goes up and down randomly and not on a clean.
When you do this, you mean moving the point?
Yeah, the single like
The tractor point.
towers are going up and down randomly.
Okay, this is because let's gonna check this part, Bianca, the distance part, okay?
Yeah.
The distance, the cool pattern you're building in the floor plan, if you select the cool pattern component, you should see something like this.
Yeah.
Okay? Then the cool pattern should be connected to the area because we are going to calculate the area, calculate the distance between those centers, those points, and your attractor point, okay, with the distance.
Ah,
Then,
okay. Yeah.
okay, then the
Now it
distance, now it works. Okay.
Yeah, thank you.
Good, good, good. You're welcome, Bianca. Okay. Anyone else with problems? We are going to do now another example with booleans. We are going to open a path in our building. Good, guys? All clear? Let's going to continue. So, we have, oh, I don't want to do this one. Yep. Let me one second. Let me see because I think, yeah, let's go to do this example, which I think is nice. We have also the rotation, but yeah, we can do. Let's go to practice a bit more with the booleans. So now let's go to open one path. Okay, so let's go to select again our definition from the other day. I'm going to one moment. I'm going to copy one of these white ones and put it here. And let's go to select the definition of the other day that has the whole building with no courtyard inside. Okay. And let's go to place it again here. Let's go to work a bit more on this. So guys, as you have seen with the booleans, we have calculated the center of each one of them and then check if they are inside one box. Okay, and this is the way we filter them with the booleans. But now imagine that my client tells me, Javi, I am working over this path here. This is Fifth Avenue. I don't know. And I want to go. There is a very nice view from this point to this one. Okay. And I want to open my building in this direction. Okay. I want to open this building with all these parametric stuff that we are doing, extruding the parts. Okay. But I want to filter them. I want to filter it in this direction. Okay. So how to do this? Let's go to draw. So the way we are going to do it is very simple, as like before. Based on those subdivisions and the center of each one of those subdivisions, we are going to draw a curve in Rhino, sorry. For example, my curve can be something like this. Okay, later we can modify this curve and play a bit with the curve. My curve can be like this. So we are going to filter my building to create a space with this curve. How can I do this? The way can I do that is, again, very similar as before. I'm going to calculate the center of each one of them. And I am going to calculate the distance between each one of those centers, even those points, to my curve. Okay, and then I'm going to filter saying, okay, if this distance is smaller than one number, I am going to cool the these cubes. Okay, these parts. Let's going to do it. Okay, this is the workflow. Now let's going to do it. So as I said, first of all, we need the centers. Okay, so area. Okay, and then we have the centers of each one of those. Good. Now that we have the center, we need to calculate the distance between each one of those points to my curve. With the distance, it's not, I mean, with the distance component, distance is not going to work, okay? Because this is calculating the distance between 2 points, and this is one curve. That, by the way, I need to put it inside Grasshopper. So I'm going to use the curve component, right mouse button, set one curve. So I have put inside this curve, okay, is here. Okay. I can do like this. You see, this is a curve, this is a point, so it's going to data conversion fail from curve to point, red color. Distance is not going to work. There is one component, if I go to analysis, curve analysis, there is here, you see the icon, right? Usually icons in Grasshopper are really, really good. If you like this feature, David Rutten, the developer of Grasshopper, published published like a guide of how to design icons. He's an architect. It's super cool. I recommend you to have a look. Also with Rhino 8, I have some friends that they are developers that they told me that there is one icon there is like a menu here to do icon designs. I don't know. I will have to take a look. I didn't check it. Can you show? Oops, sorry, there was a question here. Leona, I didn't saw your question. Is answered?
Yes, you answered it.
Yes. Okay. Sorry, Leona. I prefer you to write in. If you talk, is better because usually with the chat I usually have a look, but yeah, if I skip like 20 minutes, sorry. Okay. Thank you. Thank you, by the way. Yeah, guys. We have put inside the curve, okay? And we have those centers. So if we use this icon, this curve closest point is called curve closest point. You can write otherwise, curve closest point, okay? Is this component. You specify points, which come from the centers. You specify a curve, okay? And then what you have is a projection from the points to the curve, like this. Okay? What do you have? P, which are the new points projected in the curve. T, which is the parameter in your curve that each one of those points has. Imagine that this is from 0 to 1. This is 0.25, 0.26, 0.89, I don't know, okay? And D, this is the key, distance between base point and curve. D is giving you, if I connect here a panel, a list of numbers, okay? Which are the distances from each one of the points to your curve. And whenever you have a basic data type, remember, you can use Booleans, okay? So now let's go to use Booleans. How to filter them? Smaller than, enter. We can use this component and we can say, okay, if this number is smaller than, let's go to write a number slider, okay? And we can play later a bit with it. Number slider is going from 0.00, smaller than, I don't know, how big do you want to be your corridor or your path in your building, for example? Let's go to write 10 meters, okay? From 0 to 10. Okay, so I connected here. Then what I have is this list of Booleans. False, 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 true, false, false. Okay, that is evaluating every one of those numbers. Okay, so what to do now? Same as before. I have my list of Booleans. I have my list of elements, so in this case surfaces, which has the same structure. This and this are the same structure. So now what I can do is use cool pattern, okay? Cool this list with this this other one. Okay? You see? You see what is happening, guys? If I increase the number, more elements will be inside my list or less elements. Maybe my building could be like this. You know, I want a building that looks like, I don't know, like a path. So that will be okay to use this one. But to keep with our initial idea, what we need to do is the same as before. We need to come here and reverse or invert, sorry, the list, not reverse, invert, okay? Invert the list. So then I am creating this path in my building, okay? If I change the curve, of course, this path is going to change. Okay, so I can have like a, you see, I can have something like this. And I am doing like a inside-outside path. Yeah, Finn?
Where can I find the menu with the invert for the curl pattern?
I know, because you are clicking in the center, you are clicking the icon. If you click in P, okay,
okay.
it's super tricky. I know, it's very tricky, but it's the way they have done it. Okay,
All right. Perfect. Thanks.
you're welcome, Finn. Okay, so then we have filtered it, and now we have our buildings here. So what we have to do again is the same. Reconnect again our definition to make it work. We connect the surfaces with the area and also with the extrusion. So then we will have our building extruded that follows this path. Okay. I'm gonna play now a bit with the heights. I don't want to be so big, a little bit smaller. That will be good. Okay, so yeah, you see, and I am going to also invert it. I want the smallest here and the biggest there. So for this, I need to change my attractor point. Okay. Okay. Here we go. This is what I want. Okay, I want to enter with the buildings smaller. It's to be even smaller. Hey, wait a second. Domain start. Calculating distances. Okay. Okay, guys. A little bit like this. 9 meters, even smaller. The smallest I can have is 6 meters. Okay, so this is 2 floor plans at this time. I cannot have it smaller. And the biggest one is going to be even a bit bigger, 27 meters height. So I can have this. And now I can play with a lot of things. I can play with the subdivisions. For example, I can make it more dense, less dense. I can play with the height. I can play with the curve. For example, as I was doing before, no? If I come here into Rhino and then modify my curve, which by the way, I don't find the control points. Here we go. If I modify my curve, my building will change. I did before like a loop, you see? Oh, sorry. I did like a loop here. Okay. Maybe you're getting a more cool shape than me. Mine is a bit ugly, but doesn't matter. It's just for the sake of the example. So we have now like a wall here and a center, a building in the center. Or guys, maybe you are interested in the other way around. Like, I don't want to cool my pattern. I don't want to invert my pattern, so I'm going to leave it like this. And I want that the building follows my curve. Maybe this is another feature that you could follow. Let me make this thing a bit bigger, like this. So I could have a building maybe like this, I don't know. But for this, I will want to increment the amount of elements like this. For example, could be my building. I think that is better the other one, no? Yeah. Right mouse button, invert. Not so much, now a bit smaller. To have a thinner, I can have like, you can see like a super small corridor here. So I'm connecting both sides of the street with this building and this part of the street. Let's going to organize the definition a bit. This is to check distances with the curve. And this is to filter. Okay. No question, guys. All clear till here. Everyone could follow me. Two similar examples, okay? Two similar examples, but it's important because I need you to learn how to use Booleans. We are going to use Booleans all days from now on. Okay? And here you have your buildings. Good, good. Okay?
Can you zoom in a bit so we can check?
Yep. This is the definition. Let me put things together because I think that I don't need so big distances between parts, and then you will be able to see it better. Okay? Okay. Extrusion. Okay? Can we continue, guys? Good. Good, Kemi. Let's going to continue. So, we have one example more. That this example, sorry, I don't know, seems that I have an allergy or I'm getting sick. So I think that is going to be the second one. Uh, this example is based on those three buildings that we did the other day. You remember those three buildings are somewhere here. Yeah, I did it like this. Okay, but it's this easy example of those three buildings that we did, where we have those three curves and we extrude them based on the attractor point. Okay, so we are going to use this example today. I'm going to connect here a geometry component. Okay, to bring those three buildings from the other day into my definition of today. Okay, this is the way I'm going to translate geometry from day to day. I put a geometry component, for example, and I bring those three buildings. Okay, so what we are going to do, guys, is basically based on those three buildings, we are going to obtain the base. Okay, the base of the buildings. We are going to calculate a plane in the center of each one of those buildings, and we will rotate those buildings based on an attractor point. Okay? Good. So let's going to do it. I have my buildings from the other day, which are those three. Okay? So now for this, I need to what do I have? If I connect here a panel, I have a list of three closed VREPs. Okay, three closed VREPs. So I'm going to deconstruct VREP. I'm going to explode those VREPs. Fire, you see here? I'm going to explode those VREPs to obtain faces, edges, and vertices. If I'm going to use a geometry component, you don't need to do this for you to see. I have the vertices, I have the edges, and I have the faces. Okay? Sorry, because this we haven't seen it, and I'm going to explain it next class, I think. This is a tree. Okay, this is something that is called a tree structure, which is the latest theory part that we need to see in Grasshopper. Okay? But basically what we are having is a tree with three branches. Okay? Where each branch, each one of the buildings, okay? And we are going to obtain for each one of these items, which should be the base that is located in the base, basically. Okay, the face that is located at the base of the building. So how to do this? I am going to use, based on these surfaces, an area component again. Okay, I will always try to simplify the problem, guys, to the most simple comparison I can do. Okay, so I am going to obtain an area. So I have a point located on each one of the faces. Okay, good. If I have a point has 3 coordinates, right? So from here, the point that I want is the one that is located, that has a 0 height. Okay. In this case, it's always the last one. But guys, you never know. Really, you don't know. Depends on how they have coded these components. In some release of Grasshopper, they change components, and then this is not the last one, is the mid one or the first one, and then all your definition is not going to work, and you will have to review everything, and it's gonna take you some time too until you find the problem. The best is never rely on a structure that is coming from a component, and always do the check by yourself. Okay, how to do this check? So I can deconstruct also the point, right? The construct point, this is the component. You put a point here, and you have X, Y, and Z. Okay, X, Y, and Z. Now what we can do is, those are numbers. I can check if the number is equal to 0, right? So for checking, there is one component called equality. I usually don't like to do it with equality because it's a very, very, very tricky component. By the same problem, guys, that we had before with the points and the box. Because checking that this number is equal to 0 means that this doesn't have any decimals. And maybe even if you don't see it here, this number is not exactly 0. It's 0.00000, 2,000 zeros, and then a 1. Okay? So then it will not be the same. Even if it's the same, you know? That's the problem of mathematics. It's really, the logic is completely no fushy. It's really strict logic. Okay. Let's gonna check with equality. Otherwise, I usually like to do it with a smaller than, and I put it here like 0.0001. Okay, and then it will be okay. Okay. Let's going to do it with equality because I think that is more clear, and let's see if it works. Sometimes it doesn't. Put it here, and then double slash 0, enter. It's equal. True, it's working. For me, it's working, guys. For me, it's working, but for you, check. I'm going to use equality. If for somebody this thing doesn't work, you can use this thing and put, for example, 0.01 connected here, and the output will be the same. Okay, this you will be sure that there is no problem with the accuracy of the grasshopper. Okay, because usually grasshopper is strict also. Okay, like programming. You are now working with let's say, the core of your computer. Okay. So I'm going to use equality, and then I'm going to do the cool pattern. Cool pattern. What I want to cool? I want to cool this list of faces with this list of booleans. Here we go. Okay? You see? Okay, guys? Let me remember the definition. Evaluate surface, vector 2 points. Okay. Okay, good. I have to rotate the plane a bit. Okay. This is a bit tricky, but let's see if we can do it. Okay, guys.
Sorry.
Yes. Nina.
What was the first geometry you connected it with?
That was the boxes that we have from the previous day.
Okay,
let me
thank
show you.
you.
You're welcome. Why is not working for me? Here we go. Are those boxes that we did the other day? I need to start organizing my definition, by the way. It's a bit messy. Because I have here, for example, this thing, I'm going to delete it. Okay, so we have the surfaces, guys. Now what I want to do, those buildings are located very rigid like this, okay? Because I remember that I draw here some rectangles and I extrude the rectangles. So I am going to orient those buildings based on an attractor point. So first of all, I'm gonna place a point, set one point, and I'm going to place the point, for example, here. And what I want to do is rotate those buildings, those rectangles, according to this point. Okay? Okay, guys? To orient those buildings, for example, in the sun direction, or in a certain view that is more interesting than the others, or okay? So how to do this? I need to, at the end, I'm going to use one component that is called rotate. Okay? I think, yeah, let me one second. No, we are going to use orient. Sorry, orient from A to B, from one source plane to another source plane. Okay, yeah, and we use this geometry. Okay, good. So, from the cool pattern, okay, what we are going to do is we are going to, instead of rotate, I am going to find from this cool pattern the center of each one of them, okay? I am going to place a plane, and then I will orient those planes with another plane that I'm going to create based on my point and the distance, the center of each one of them. Let's going to do it, okay? The component is called orient, the one that we will be using at the end, okay? But there is one thing that you need to do, guys, otherwise it's not going to work. Out of the cool pattern, the structure is a tree, okay? But I want to rotate these buildings that I have here. I want to rotate those buildings. So for this, I need to flatten the same as we did before with the P that we click on invert, okay? On the Boolean. Now we are clicking on L of cool pattern, right mouse button, and flatten. Okay, so then we have a list. The wire should have two lines like this, those two lines. Okay? So I have those three, right? So what I'm going to do is, first of all, find a plane, find the center of each one of them. Okay? Here we go. We have this center. Okay? And then I think that we can do it with construct plane, for example. Then let's going to build a plane on each one of those centers that the plane is going to be like this. Okay? X by default, Y by default on every one of them. Okay? Do you see the planes, guys? The plane display in Grasshopper is also different. You have to go under display, preview plane size. Okay? And here I have, for example, 25 meters. I'm going to put 10 Okay, you see that the plane size has changed. So when I click on plane size, the size of my plane, where is the display? Preview plane size, you can change it here. Okay? It has changed. Now it's smaller, a bit better. So here we have my planes, but I am going to build another planes based on the same points, okay? But the orientation of those planes are going to be different, okay? So the orientation of those planes are going to be based on another plane that I'm going to build here. How do I build another plane? I can modify the X or the Y. I think I'm going to modify the Y direction. X is the red one, Y is the green one, okay? So I'm going to modify the Y direction of these planes. The Y direction, I can do it, for example, introducing a vector here, Y-axis direction of plane, okay? So let's going to build a vector of 2 points, vector 2 points. Here we go, okay? The first point is the center. Point A is the center. Point B is my point. Okay? But I need also to rotate this one. Okay. I think that I use it with the vector 2 point, yeah. Yeah. And then I rotate this one 90 degrees and put it on the X. Yes. Okay. The problem of this component, guys, is that let me connect this one here and disconnect it here. The X is working, but the Y is not. But I don't want to orient my buildings. You see, what I'm doing now is I am orienting the planes based on the X one. But I want to do it with the Y. This component by default works with the X is the primary one, and the Y is considered secondary, okay? So if you want to do this thing like this, I think let's gonna try to rotate this vector that I'm calculating from this point to this point, rotate 90 degrees, and then connect this to the X. I think that this will work. Rotate, reveal surface. I think that I have used this one. I think that, yeah, that should work. Yes. So the geometry, I think that is working. Yeah. And the angle is going to be 90 degrees. Okay, we are going to do a rotation of 90 degrees of this vector. I can explain again everything later to make it a bit clearer for you, okay? Because this is getting a bit complex. The thing is, 90 are angles in degrees, but here, as every computer works with radians, not with angles. If you want to work with angles, right mouse button on the A again and click on degrees. Okay? And then I have here. Here we go. Now this is working. You see? Now this is working. I have the Y oriented into my point correctly. You see? The green one. I can do it with the X also and delete this part if you want. It's fine also. There is no problem with this. Okay? So now, orient. What are we going to orient, guys? We are going to orient our buildings, okay, from plane A to plane B. Ta-da! And then, yeah, and then change it the thing. I can explain you why this is happening. Everything has the same problem as me? Everyone here with the same problem as me?
can you maybe zoom out a bit so we can see which
Yeah,
wire?
let's go to see it together. This is, I think, a very interesting exercise. It's a bit tricky, but let's going to try to fix it together. So let's gonna go again. Okay, guys? I start with my buildings. Okay, with my 3 buildings. I deconstruct the surfaces of my buildings and find the bottom face. Okay, find bottom face of my building. Okay, like this. Find bottom face of my buildings. Okay. Then what I do here, this is my attractor point. Okay, attractor point. Here we go. So I calculate a vector between the center of each one of those buildings to my attractor point based on this. Okay, and I build a plane. This is my building plane, we can call it building plane. Okay, and this one here is the orientation plane. Let's going to call it like this. Okay, so how I am getting my orientation plane? Where is it? I'm gonna try to go lower to do not mix definition. My orientation plane is calculated based on the center of each one of those buildings to my attractor point. I calculate a vector 2 points and then I calculate my plane. The problem that I'm having is that then I try to orient my buildings and I try to orient my buildings from this one to that one. Okay? From this one, which the X is in this direction, to that one. Okay? That the X you can see is going in the opposite one. Okay? You understand what is doing this? Because when you try to match this plane to this one, is flipping the plane. The easy way to match this plane like this to this one is flip the plane and rotate it. Okay, that's why my buildings are rotated in the direction of my attractor point, but they are looking downwards. Okay, you see? The way to fix this, I think that creating a vector, let's going to construct a vector. How was this thing? How to construct? I always forget about vector XYZ. Yes, vector XYZ. This is the way to construct a vector from scratch, guys. This is the vector 0, 0, 0, I think. Yes. So let's go to write here -1. Let's gonna flip the X direction and let's going to connect it here. So you see, the plane was like this, and now is like this. I have flipped the X vector. So if I flip the X vector, the orientation to this plane is just a rotation. You see, nothing more, just a rotation. You don't need to flip it and then rotate. Okay? Orient is a very useful component, but a bit tricky. You need to understand how it's working. This is to let's say orient correctly our building plane. Everyone here, I know that this example is the most difficult one we have done till today, I think, but it's also very useful.
My construction planes are going in very wild directions, so they're going
That's good. That's good. That's good. Let's gonna start from the beginning. Cool pattern. Did you flatten the output of the cool pattern?
Yes, I did.
Yes, nice. So then we have the area component coming out of the cool pattern, Leona. So
Yeah.
an attractor point, right? But we generate the vector 2 point, and this is very important. The vector 2 point is generated. The A comes from the C of the area, and the B comes from the attractor point. Okay? Good?
Yes.
Yes, nice. Then the construction plane. To construct the plane, you need to connect the vector 2 points is going to be your y. Okay, so we are going to rotate the y. Okay, the thing is to make this work properly, to rotate the y, you need to also indicate the x, because otherwise it's not going to work. To do this, what I have done is I get the y, the vector, and I rotate this vector 90 degrees, because by default, x and y are going to be always 90 degrees. You understand, right, Leona? So you rotate, you put here 90, which is degrees, but this component works with radians. So the I, you have to do right mouse button, degrees. Okay? And then you will see this icon. Okay? And then connect this one to the X. You have this plane rotated. Okay? So now if you move, try to see if this is working, first of all. You can see the planes moving like mine, like the green one oriented to your point.
Yeah, I think I found a problem. My attractor point was in the sky, so it.
Okay, but you found the problem?
Yes, I did. Thank you very much.
Okay. Thank you, Leona. Sorry. And then, now that I use Leona to go through the definition, the construct plane, everyone should look at like this, okay? And then the building plane. The thing is, the building plane was built like this, you know? X looking over there, because this is the default in Rhino. And I want to orient those planes into this one.
Sorry, may I interrupt? I guess I have the same problem like Leona, but I don't know how to figure it out. I created a monster from a lot of directions, the geometry.
Let's going to do one thing. Tianji, can you show your screen? Will it be possible? Tianji, you have muted yourself, I think.
Yeah, moment.
Yeah, 1 second. I'm going to stop sharing.
How did I?
How do you share?
start?
1 second.
Yeah.
Yeah, you will see one menu now.
Yeah. Is the green arrow?
Yeah, the green one. Click on share. Yes. Allow 1 second. Here we go. You can share now.
Can you see my screen now?
Let me check. I can't. Guys, can you see the screen of Tianji?
No.
No. Try again, Tianji, 1 second. Yeah, try again to share. Stop sharing and share it again.
I guess you
yes.
can see it now.
Now, yes, now I can see it. Good. Okay, so let's see what is the problem. Show a bit of the Rhino also, and we can have
Yeah, you
fun.
can you can look at that's my Rhino model now.
That's
crazy.
Hey, this is super cool.
Yeah, but it looks cool, but I don't know what's the problem.
Okay, let's see where is the problem.
Yeah, actually I can sense perhaps because also, but I did do the flatten button, but still.
Okay, let's go
yeah.
to start from the beginning. 1 second. Select the buildings that you have. Select the geometry component.
The
Okay,
very beginning.
let's see Rhino.
Yeah.
Okay, so you start from scratch there with the 3 buildings. Okay, can you show Rhino and Grasshopper at the same time? So
Yeah.
so yeah, perfect, way better. Yeah. Amazing. That's enough. Okay, so now zoom a bit there. Yeah, let's see what you have. Click on the cool pattern. On the cool pattern. Yep.
Yeah.
Let's see. There is a problem here because you haven't cooled the surfaces. You are working still with the whole building. Okay, so smaller than 0. Yeah, I think that smaller than is not working for you. That's the problem, TNG.
So
So
here,
double click.
disconnect.
Yeah, double click.
The smaller one.
Wait a second. Go for the list. I mean, what is the input here? The list input of the cool pattern. What is the input? You have the cool pattern that come from smaller than. That's good. And then what are you cooling? Go for the left. Let me see a little bit more of the grasshopper. Okay, this is fine. You're cooling the faces. Okay, so then do one thing. Connect a panel to a smaller than. Create a panel. Double click. Double click. No, no,
Yeah,
no,
this
no,
one.
no. No, not this one. Double click on the canvas somewhere.
Canvas. Which one do you mean?
Yeah, in Grasshopper, double click
Yeah, this one.
No, no, no. In whatever, just how do you do to search a component? PNG. When you want to place a component, how do we do it? Double click.
Do you mean this one? Okay, yeah.
Yes, double click and then double slash. No, double slash like this, like to create a panel or bright panel. Bright panel. Panel.
Sorry, what do you mean?
Panel.
So
Bright
just a panel.
panel. Yes,
Yeah.
yes. And then connect this panel to a smaller than.
Okay.
Smaller than. You have to do the other. Yeah, okay. And then let's go to see your list. Open the list. Yeah, open the panel. Yeah. Okay. You see, guys, what I told you before? For Tianji, it's not working. You see? You remember, Tenji, that I was speaking about this before, right? That sometimes a smaller than is not working because, yeah, I know what is not working. You use a smaller than, not equal. Okay? Change the 0. Go for the 0 input in your panel.
You mean this
Yeah,
one?
double click,
Yeah.
0 point, right, 0.01, for example, okay? A super small difference. Now it's working. You see the true there, right? In your output. Still, yeah, a smaller than is true. Hey, wait a second.
But still, I think this one doesn't look correct. Or it
No, it's not
should be
correct.
on the same.
It's not correct still. Go for your, there is something weird here. Go for the left. Left. Okay. Can you move a bit the panel 001 upwards? Because move it up. Yeah, okay. You are deconstructing the faces, right?
Do you mean this one?
First number. Can you check the set
Maybe I
component?
have an idea.
Yeah, Clara.
So you have the cool pattern, and you have the P, and there's I don't know, the invert. Maybe you need to quit the invert.
Do you mean this one?
Yes, right. Maybe this is the problem.
Yeah, because you have inverted this one.
Yeah.
Nice.
Okay.
Thank you very much, Clara.
Yeah, now I lost my crazy structure. Okay, thank you very much.
Oh, I really like your crazy structure, Tianji.
I will do it again. Just humor. Okay.
That's good. Thank you, Clara, because I was not yeah, let me share the screen 1 second. I know, and then I understand what was happening. Yeah, I was missing this point. Tianji was here inverting the pattern. He did like right mouse button, invert the pattern. So then I want to see also if I have a so cool thing like Tianji. And then, yes, and then he was having something like this. Okay, so yeah, the thing is, then if you invert the pattern here, what you are getting is all faces except the base. You see, Tianji, here I get all faces except the base. That's why you see the points here. And then that's why you got this super cool, crazy thing. Yeah, red mouse button, invert again. Okay. And yep. And this is working. Good, guys. Sorry, because I know that this example was a bit, sometimes things that look easy in Grasshopper are not easy, just to rotate a building, sometimes it's more tricky. But yeah, it's more tricky than doing the cool building from VR Kingdoms. Good, guys. So with this, we will continue next day working from here, from the Orient. Okay. So yep, and we will be using those oriented buildings. Okay. Yeah, nice. Good. Any questions still here? Everything clear? Those three definitions that we did today. I'm going to copy paste also one spacer here, one of these panels here. Everything clear here? Good.
I wanted to ask a small question.
Yes, Sasha.
Like, I think you have this setting that when you zoom to a component, you see. No. Okay. Because there was this function like that you move into a component and you see what kind of data it is using, the input and the output. Like it shows it's a tree or a list or anything else. I think I don't have that.
What I do, Sasha, is just keep the mouse in the input, and I see here what is the input, and if I keep the mouse in the output, I also see the output. You see here? For example, here, I see like this, but usually I do it like this with the mouse, or double click and I connect a panel.
Okay.
That's the way I do it. I know that there are some plugins there that there are a lot of plugins to work with Grasshopper for the visualization and this stuff. I usually don't like to use them, but you can try.
Okay. No, I think I had it before, but like, yeah, I see. Just with the mouse is okay also.
Yeah.
Okay, thanks.
Okay, guys, you're welcome. Hey, today was funny. We did 3 definitions today. Nice. No more questions then?
I have a question again.
Yeah,
Sorry. Like I try to compare everything and I think it's the same as you have it, but at the end I have 9 buildings instead of 3.
9. Okay, let's go into. Can you share your screen?
No, because I'm with my iPad.
Okay. So you have 9 buildings.
Yeah.
This is a problem with the data structure, Bianca. Somewhere, I mean, you did hear the flatten out of the cool pattern?
What?
Flatten? You did in the cool pattern?
Moment.
You flatten?
No, I didn't. Moment.
If you didn't,
oh yeah, it works.
Then that's why you
That's
have. If I don't flatten, I have here suddenly a lot of buildings.
Okay, thank you.
Good, super easy. Thank you.
So what are we supposed to put into the submissions for this
In the
class?
submission, yes. I was expecting somebody asking for the submission. Let me check, Leona. So for this class, I'm not going to ask for this first partial submission. You don't need to include this third class. Okay? You don't. If you want, do it. But compulsory is classes 1, 2, and 3. Okay? It's only those 3 classes. If you want to include today class, also good. But answering your question, Leona, what should be included there? My recommendation is choose one of the exercise that we did, or this one, or this one, or even the buildings. And you can play also changing the size of the buildings, for example, and the rotation. Even if the size is coming from another day, it's not coming from the class of today. You can choose one of the three of them and fill all the images that are requested there. Okay, Leona? And
Yes,
that's all.
thank you.
That's all. Easy, okay? I give you until Sunday, so if somebody wants to have a little bit of fun this weekend playing a bit with Grasshopper that we did today, I recommend to do it. And you have questions, write an email, okay? Good, guys.
Sorry, can you zoom in to the first one? First
Oh, yeah, sure.
exercise?
Yes, sure. 1 second. First exercise we did today, you mean?
Yeah, just to compare and organize it.
Okay, Masha, 1 second. First exercise is this one. Let me. Solution. This is the first exercise of today.
Thank you.
You're welcome. Can filter here. The only new part, Masa, from yesterday was this part. It was the only new part. The rest is the same.
Okay, thank you.
You're welcome. This. Copy this. Okay. Well, guys, I hope that you have learned today with me Booleans. We are going to use Boolean the rest of the course. And yep, if there are no more questions, good. Okay, so I'm going to stop recording then. Stop.